Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you are joining me live or you are watching the recording, I appreciate you watching. Thank you for joining me today as we start to talk about Python. As we get started here, this is just kind of an announcement that this is a multiple week module, right? Like, this is not just a 1 week module. We are covering Python over the course of a couple different weeks here. So we'll be covering this material even more so next week, right? So this week we are just getting started, and we'll be continuing next week, which is pretty good. Because it does take some time, right? Whenever we're starting to do something like this, right? Kind of as we discussed last week, right? It does take some time when we're dealing with stuff like this to get into it and kind of wrap our minds around things and approach problems in a new and different way. And I think that's, a good thing for us to sort of do there. So we're going to talk about Python this week. We're going to talk about our environment that we'll be working in this week. And we'll be doing a few different things in our Python environment this week. But a lot of the meat and potatoes of the stuff that we'll be doing will be done next week. And I might be posting a handful of things as well, just to kind of supplement what we'll be doing here in addition. But before we get into any of that, let's just kind of define some terms. Right, we've kind of defined some of these terms before, but let's get into some depth here with some of these terms, and let's just define what a program is. Since we're going to be programming, I do think it is important for us to define what a program is. So for our purposes, a program is just a sequence of instructions that specifies how to perform a computation. And so when we think about a computation here, we also have a definition of a computation here. We say a computation might be something mathematical, such as solving a system of equations, finding the roots of a polynomial, but it could also be a symbolic computation, right? Such as searching and replacing text in a document, or something graphical like processing an image or playing a video. When we get down to performing a computation, all we're really talking about there is, kind of an algorithm, right? Like, we looked at algorithms a little bit last week. The idea of an algorithm. And we said an algorithm is really just the steps that we take to solve a problem. And so now we're saying, well, we're performing a computation, and this computation solves a problem. So it's really just a different way of saying the same thing, right? A computation is an algorithm, and an algorithm is just a way of solving a problem. So we have some experience now with developing a sequence of instructions that specifies how to solve a problem, building an algorithm that is a program. Right? Last week you were all asked to take a task. So the type of task that seems like an everyday, individual, sort of mundane task, and write out all the steps that it would take to complete said task. And I think many of you found as you were doing that process that maybe this was a little more difficult than it might have originally seemed. Maybe these everyday tasks, when we really break them down and we try to think about every step that we take to solve a particular problem, like we're a computer, like we are, just coming on board to Earth. It's our first day here. When we start to think about problems in that sort of way, then we kind of realize that, maybe these everyday simple tasks, maybe while we do them every day, maybe they're not quite as simple as they seem, right? And so these instructions that we wrote about in our algorithm for our discussion last time were simply that, right? Just instructions, different specific things to do. Well, for the purposes of our program, an instruction is simply a line of code, right? Because a line of code is just basically telling our computer something to do. Now we have a sequence of instructions. We have different types of instructions that meet every single sort of need in every single programming language. We have a certain type of instruction that can do the job. And the way that we write these instructions are different between different programming languages. But the types of instructions, or at least for a few basic types of instructions, the types of instructions are the same in every single programming language. And these are the types of instructions that we're going to be seeing as we're working with Python, and in the future with other programming languages as well. We'll be using these same types of instructions. And so these are inputs where we're able to get data from a keyboard, from a file, from somewhere that is not the program itself. Outputs, being able to take data and display it on a screen or save it in a file or send it somewhere that's not the program itself. Being able to perform basic mathematical computations, or being able to do math, being able to do addition, subtraction, multiplication, division. We'll introduce at least one new mathematical operation for you all as we talk about Python here. And then conditional execution, being able for our programs being able to make decisions, to being able to check for certain conditions and then run code where appropriate. So if something happens, then we can run a certain set of code, and if it doesn't happen, or if something else happens, then we can run some other kind of code. And then finally, repetition, being able to perform some action repeatedly, usually with a little bit of variation to it. There are multiple different ways in programming languages that we can typically do this. Oftentimes this is either done through recursion or through loops. Since recursion is a bit more of an advanced concept, we'll save those for future classes, and we'll start out with just looking at loops in this particular course. So while we might notice that different programming languages kind of look different from one another when we are writing them out, Java looks different from Python, looks different from JavaScript, looks different from C++, from C#, from COBOL, from every other programming language that exists. We still find these same 5 basic instructions, or 5 basic instruction types at the core of each of these programming languages. And having each of these 5 core instruction types is at least part of what we say makes a programming language Turing complete, named after Alan Turing. To say that a programming language is Turing complete. Many of you wrote about Alan Turing as your key historical figure in your Module 1 research assignment. Right, Alan Turing contributed here as well. And so we say that, every programming language has all of these things. We're going to start with a particular programming language as we're starting to write code here. And that programming language that we're starting with as we're starting to write code is Python. So what is Python? Python is a programming language. Python is a programming language that was created by Dutch programmer Guido van Rossum. And we say that Python is a high-level programming language. And we talked about the differences between high-level and low-level programming languages previously. right? We said that, the higher, a high-level programming language looks closer to English, whereas a low-level programming language is closer to machine code, closer to binary. Right, closer to it depends on whether it's closer to something that we can easily understand as human beings, or closer to something that our computer can understand, whether it's high-level or low-level programming language. It is open source and community-driven. And this gets back to another thing that we talk about a lot. There isn't really a programming language that exists in a vacuum. Right? If I search online, I can Google Python GitHub, and I can find the source code for the Python programming language. This is it. Right here. So when we say open source and community driven, we mean that people can contribute to the source code. People can contribute to building the language that builds the code. Programming languages don't exist in a vacuum. Somebody actually has to program programming languages. And if we look at the programming language here, we see that we actually use other programming languages to program our programming language. So if we dig into it here, we discover that Python, created with C. Here we can see all these .c files here. And so we're using the .c programming language to help us build another programming language, which is Python. So it's open source and it's community driven. People actually fix it. And we can actually see that if we go into here, right on GitHub. We can see issues that people have found. Problems, bugs in the code. And we can see places where people have tried to make some fixes, where we're waiting on things to be merged or not merged, as the case may be here. And we can actually see, if we look, we can see a history of 114,643 commits. And these are times where contributions have been made to the Python source code. Python is said to be a batteries included programming language. Right, which means a standard distribution includes many different modules. What we see a lot of times in a programming language is that there are some things that programmers do that they do a lot, that we know they do a lot, where we've already written some code for that, so we don't have to write code for it over and over and over again. And we do that in a module. Right, one of the ones that we might have a look at in a little bit later on is the math module. Right, for example, if we want to there's certain advanced mathematical functions where if we want to do the mathematical function, we could go through and program everything out line by line and do it that way. But we know we use it a lot, so they just went ahead and included it in a module. And so we can think about a module. Another word for module in some cases is also library. We can think about a module like a book in a library. Right? So where if I need the information that's in a book in a library, I can go and I can check that information out, and I can read that information, and I can use that information just as I need to use that information. And then when I'm done with it, I can give the book back to the library and it's just fine. I don't have to have that book all the time, so I don't have to carry it around with me all the time. I can just use it as I need it and give it back. Comparing that to our program, I can just call it in when I need it. use it when I need it, and then when I don't need it, I don't have to use it, so I don't have to bloat my program with a lot of extra library files and things of that nature that I don't necessarily need all the time. Python is dynamically typed, which is friendly for us starting out. Right, one of the things that we talk about in depth in future programming classes are the ideas of data types. Right, every data type that exists, or every piece of data that exists, has a data type that goes to it. Characters, words are typically called strings. Whole numbers are integers. Decimal numbers are floating point numbers. Right, and in many different programming languages, if you are going to use certain data types of data in functions, in variables, in various things throughout your program, you have to start out by making a promise to your program about which types of data you are going to use where. Python does not make me do that. Python, I don't have to make that promise. I can use any type of data at any time. Python is, in general, friendly to me. Right? It has some specific rules to it. Things that we've talked about before, right? Like the idea that, we have to be specific and deliberate when we're typing. If we create a variable and it's all lowercase, we need to make sure it's all lowercase everywhere we create it, because our computer is not smart enough to know that a word that starts with an uppercase and a word that starts with a lowercase letter, they might be the same letters, even though one's an uppercase and one's a lowercase. They're two different letters to our computer. Right, but Python's a little bit friendlier because it doesn't require us to make the promise about what type of data we're going to be using at any particular given time. Although we do need to concern ourselves with data types just a little bit, but we'll talk more about that when we get to inputs a little bit later on. So why Python? Python is one of the most widely used programming languages in the world. Right, when we made the decision of which programming languages we were going to include in our introduction to in our programming and logic, or in our programming and web development degree, I should say, program here at CCC, we kind of took a step back and we looked at the most widely used programming languages in the entire world. There's actually a survey that's done every year that examines the usage of programming languages. It looks at contributions to programming languages in GitHub. There's interviews of people that are done about, what they program in at their jobs. And it found that 3 programming languages above all others were the biggest in the entire world. And these were Python, JavaScript, and Java, in no particular order. I actually think JavaScript was the biggest, and then maybe Python, and then Java. Rounding out the top 5 might have been, if I remember correctly, C++, and what was the 5th one? Don't recall right offhand, not really important right now. Not a big deal. Right, but these are the 3 most widely used programming languages in the entire world. When I was learning to program and I was an undergrad at the University of North Carolina, the very first class we had where we started to learn to program, they gave us a teaching language to use, which is not uncommon at a university level. Right? We used something called Turing, which is sort of a JavaScript variant, Right? If you were to look at it side by side with JavaScript, it would look pretty similar. It was named after Alan Turing, again, like a lot of things have been. Right? But it's not really a program that's used in the real, it's not really a programming language that's used in the real world. Right? It was primarily just used to teach students how to program, which, that's all well and good. Right? When you're learning how to program, to have a language that's friendly to you, to learn how to program while you're learning how to program is pretty nice. But I think it's more important to not only have a programming language that is friendly to you to learn how to use while you're learning to write a program, but also have it be a programming language that is relevant and is utilized and is actually something that people use that are writing programs in the world today. Right? Python, by and large, is used in data analytics, big data applications. It's also used in software applications, even some gaming applications, mobile and web applications through web frameworks like Django or Flask. There are a lot of different applications that Python is used for. It is highly flexible and highly utilized. It's also been around a long time. It's actually been around since 1991. And a lot of people, when they hear that, find that hard to believe. Even those who have been programming for a little while now or have been familiar with Python for a little while now, because we didn't really start hearing about it a lot until about maybe 6, 7, 8 years ago. Right, but by that time, it had been a coding language for a long time. It just wasn't really being used in particular settings. Right, so now that it's gaining popularity, it's gained a lot of popularity. It's more present, and it's more used. It's also easy to get started with. We'll see that as we work in it. And it allows us to focus on learning programming logic, which is where a real challenge is, without having to struggle with syntax. Syntax in Python, relatively easy, right? There are a few different challenges we'll highlight along the way, whereas, the logic that we'll have to determine as we're kind of going through will be what we need to sort of figure out and work with as we progress. It is all right. It's called Python because of the TV series Monty Python's Flying Circus. Guido van Rossum was a big fan of that show. You might be too. I don't know. Maybe you are, maybe you're not. Who's to say? Running Python. For simplicity's sake, we will be using an online IDE. An IDE is an integrated development environment. This is Replit. You should have made your Replit account way back in week 1 of the class, way back when we did the Begin Here module. If you didn't, you'll need to make it as soon as possible so we can do our work here. You'll need it basically for the remainder of the class. Starting now throughout the end. Replit. It's repl.it or replit, replit.com. Either URL will get you there. The URL is in the Begin Here module of the course. I also might have thrown it in module 4 as well. I don't quite remember. If you'd like, which I don't recommend you doing it, you can use the standard Python IDE, which is called Python Idle, which is installed when you install Python on your machine. One of the great parts about using the IDE or the online IDE Replit is that you don't have to install anything, for one. Right? You just have to make an account. So especially for those of you who have Chromebooks, that's good there, right? Don't have to install any software. You can just use this in your browser. And we'll also see things like it gives us hints and things of that nature as we are as we're working. We will be using Python 3, which last fall that would have meant something because Python 2 would have still been in existence. Python 2 has since been sundowned. So now Python 3 is the only version of Python that is being supported. So let's open up a Replit and let's get our environment going, and we can start working in it and doing a few things here. Your environment window will look something like this after you log in. It might not look exactly like this, but it'll look fairly similar. Right, you'll have some kind of advertising, have some trending replets here. Probably won't have anything here until you have created something, because these are my most recent REPLs. When I want to create a new REPL, and this is after I've logged in, by the way. So you'll want to log in or create your account first. But after you log in, you'll land on this page. I typically keep mine on light theme because it's easier to see on video and on overhead screens. But they do have a dark theme here for those of you who like the dark theme. It's the little moon that's down here in the lower left-hand corner. But once you're ready to create your first REPL, they want to make it easy for you to create your first REPL. So there is a create button here in the upper left. There's this create button in the middle. And there's this plus sign here in the upper right. So again, right, we have this create button here, a create button here, and a create button here. Three different create buttons. We can press any of these buttons to create our new REPL and make our life easy on us. And that'll bring up this modal screen. By default, yours will probably look... Yours definitely won't have these favorites here. It might not have anything there. But we want to search our templates to find our template. So we will search Python, Python. And we'll see some different things down here. Right? You'll find like, oh, there's Python 3.10, Python CMU Graphics, Python Data Science, Python Discord Bot, Python PyEnchant, Python with Turtle. We don't need any of that. We just want the regular old Python. Just Python, one word. Just Python, nothing else with it. It'll come from Replit instead of someone else. And we'll click that as our template. And then we will want to give it a title. And so I usually have to give mine longer titles because when I give these demonstrations, I'm typically giving them twice a semester because I have a seated class and an online class. So this will be CTI 110, Fa22, OL, first program. And then we'll click Create REPL right here. And that'll give me my environment. We'll see here I have a file panel. Here to the left-hand side, that might be collapsed by default. If it is, we just want to click this little piece of paper icon here at the upper left. That'll open it up. I have my code window here in the middle. This is where I'll type my code. And I have my console window here on the right. This is where my code will, or my output will show up, I should say. Up here in the upper right-hand corner, you'll see a little three-dot menu. I can kind of change some things up here. If I want to move some things around, add a new tab and do some things around there. I can also change the way this looks from my settings menu here, I believe. Yeah, we got our default layout here. I could have a stacked layout, which puts everything on top of one another. I prefer the side-by-side layout. But this is our code window. And so from here, we can actually start to write code. I'd like for us to just take a few minutes and look at the console window here for just a few moments. Now, one of the things that I might want to do is I might want to check to see which version of Python is on a machine. And so if I want to do that, I can come to my console. I'll zoom in so we can see this a little bit better. In fact, before I do that, let me just make sure that I have... All right. And I can type in Python --version. Version. And oops, I should actually do that in my shell instead of my console, not my... I have a shell here. That's what I want to do that in. Python --version. And so we see we're in Python 3.8.12. If we visit our Python programming language website, python.org, we see that the current version is, let's see, there's a 3.11 release client, which means 3.10 is our current active version. So there are a couple of versions behind, but all the stuff that we're doing anyway is all universal, right? So it's fine that there are a couple of versions behind. In our console here, which is what I want to do in my console, getting ahead of myself, so one of the things that I can see is that my console will evaluate things for me without having to write code. I can put in just some standard like numbers. If I can get my console to respond to me here, it should allow me to type into it here. Okay, there it goes, finally. Just running a little slow. I can type in a number, and it'll echo it back out to me. Right? I can type in a simple math equation like 32 plus 15, and it'll evaluate it and give me the results. 87 minus 56, it'll evaluate it and give me the results. So this is actually the Python interpreter in the background doing this math for me. Right? Remember one of the things that we said before when we were talking about history? A lot of the things that have happened when it comes to the innovations in computing and programming and all this kind of fun stuff is because math is hard. Right? So math is kind of at the core of everything that we do because math is hard, right? So if we have our console selected here, we can clear out our console here by clicking this trash can. And we are ready to kind of write some code. Now, one thing I do want to warn you on is do not rename this file. You can retitle your program by going up here, clicking on the title here at the top, changing the title here. Do not rename this file here. Or when you click this green run button here, it will not run. When you click this green run button, it is looking for a main.py file to run. So just keep that in mind. So let's talk about the first line of code that we're going to run in our program, which is going to be our shebang. So our shebang is a special bit of code. Whoops, forgot to turn off the countdown. Our shebang is a special bit of code. Insofar as our shebang really isn't much of a bit of code as it is, right? A shebang has a specific purpose to it. But every Python program that we write should start off with the shebang. The term shebang is a portmanteau, which portmanteau is just a fancy word meaning two words that we've mashed together, for hash, for hashtag, and bang, which is another word for exclamation point. Right, and so when we have a shebang, basically all that means is it's telling our computer that if we have Python installed on our computer, if you double click this file, it will run automatically. That's all it does. Right, so we don't have to go to a command line and run it or do anything special with it. If we download this file to our computer and we have Python installed, if we double click a file that has the shebang in it, it will run automatically. And our shebang is located, looks like this right here. Hash bang, or hashtag exclamation point, /USR/BIN/ENV Python 3. So we can add that to our program. So we're going to do that here. Hash bang /USR/BIN/ENV Python 3. So now we have a shebang. And again, all that means is that if we downloaded this file to our computers, this .py file, and double clicked it, it would run automatically. Now, when we were doing our history stuff before, we looked at some hello worlds. And normally the hello world is the first programming assignment, but our hello world in our Python is just too easy. Right? So I don't assign a hello world in a Python class. I might assign it in a Java class or in some other sort of more complicated programming language. But I don't assign it in a Python class in which we see our hello world. In just a few moments, you'll know why. But just as a reminder, our hello world is basically just a coming out party of sorts, just to say hello, that we are learning this programming language, that we are introducing ourselves to the world of Python programming. So let's write our Python hello world there, and we will have created our very first Python program together. So on a new line, I'm going to hit another line break to space out to another line. And I'm going to write print, which is our output. And then in quotes, hello world, exclamation point. And I am done. This is the Python hello world. It is 2 lines of code, and one of the lines of code we said I don't even need. Right, which is pretty cool. So when I run this now, I will get hello world echoed back out to me here in the console, which is pretty cool. And that's actually one of those 5 things that we talked about earlier that's in every single programming language. Right? We said there are 5 things: inputs, outputs, math, conditionals, and repetition. Right? This is outputs. So we use our print statement in Python to give us an output. So every time that we want to take something and print it out to our console, we're going to use our print statement. So we're going to take something and print it out to our console. So let's take it a step further and let's talk about math, for example. Maybe some arithmetic operators, right? The next step after our hello world is doing a little bit of math. So we have our basic operators here: addition, subtraction, multiplication, and division. Right? Oh, man, we're already moving on to a second one of those 5 things that we were talking about earlier, that we said every programming language has, right? Once we got to working on those, we started moving on them fast. I mean, we just learned about an output, and now we're doing math. Exactly, right? So we can go in here into our programming language. We hit enter. We hit enter to make a new instruction. So every new instruction that we're making, we're hitting enter to make a new instruction, a new line of code. And we can print, and we can put a math equation in between, something like 45 plus 23. Right? And as we get started, this is the kind of thing that I recommend. Is to just keep our programming simple. 45 plus 23. Oh, okay, that's 68. Right? That's a math equation that I can do in my head really quickly and easily. So I know that if I get that on the output, then I got it right. That's great. And so my interpreter works from top to bottom. So it will go from top to bottom. When I click run here, it will print hello world, and then it'll print the results. It won't print the equation. It'll print the results of the evaluated math problem of 45 plus 23. So we see hello world and 68. And we can do that with all of our basic math equations, right? Print maybe 1,740 divided by 20. Print 99 minus 38. Print 4 times 25. Right, just basic mathematical equations. And we're getting our calculations done here. Now, in a lot of instances, we do have to be specific, but we can put some spaces between our mathematical operator and our numbers just to make them a little more readable. And I would recommend you doing that. So now as we execute that, right, it's going to work from top to bottom. And it's going to give us the results of each of our math problems here as we see them. Right, so what do we have here? We can just run it. Hello world, 68, 87.0, 61, and 100. Now we got one weird outlier here that's a little bit weird, that's a little bit different from all the rest of them. And that is this 87.0. Right? And that's because that's the result of a division problem. Right? So when I divide numbers, even when I divide whole numbers, I could have a floating point or decimal number as an output. In this case, we didn't because we kind of planned it not to. But I could have one. So since I could have one for precision's sake, while Python doesn't need a promise about the type of data that you put into it, C, the programming language behind Python, does. So when we get into instances like this, where we're doing division and we want to have a precise output, we're going to go ahead and do what we call typecasting, which is where we take what we're putting into it and automatically convert it into a different data type. We'll actually have some practice with that probably next week as we are working with some inputs to do some different things, which is pretty interesting. But that's why that's 87.0 instead of just 87. Right? Because my programming language is forcing that to be a floating point number so it can do its division calculation. And so we have all of these different basic calculations. Right? We can also put all of them together, right, for order of operations. Right? So if I wanted to say like, 13 plus 7 times 9. 13 plus 7 times 9. Now Python follows PEMDAS, right? It follows my order of operations rules when I'm using multiple mathematic operators in a situation like this. So, what it's going to do with this number here is it's going to do this calculation, 7 times 9, and then add 13 to it, which is going to be different than print 13 plus 7 inside of parentheses times 9. Right, so that's just to kind of let you know that if you're doing some of these advanced calculations, you want to make sure that you are putting parentheses in there just to be clear about the order of operations that you want to take place. Or else we could end up like we have here, where we have two very different solutions to the problem. And in such a case, right, 76 and 180 are widely, vastly different numbers. Right, so when we're looking for precision, it's a big deal. Now we do have some other arithmetic operators that we can work with. One is exponential notation, which is 2 asterisks. And there's the modulo, which is always fun, which is the percent symbol. So exponential notation, or exponents, right, we probably know, right, like if I have 3 raised to the power of 2, or 3 squared, that's 3 times 3, that's 9. In Python, we would write that as 3 asterisk, asterisk, 2. And that would be the same thing as writing this, right? We just don't have that superscript available to us. Modulo is the remainder of a division problem. So if I were to say 2 divided by 4, 2 goes into 4 evenly, so the answer is 2, but the remainder is 0 because there's nothing left over. So the answer to 4 modulo 2 is 0. Whereas 4 divided by 2, or 4 divided by 2, is 2. Right? The answer to 4 modulo 3 would be 1, because 3 goes into 4 one time with 1 remainder. It's that remainder number that we're looking for there. And this is actually something we use, that we'll see in future examples, that we use for finding out whether a number is even or odd. Because if we can check it modulo 2, and if it doesn't have a remainder, we know it's even, basically. So let's do a calculation here really quickly. What I'm going to do here is I'm going to put a comment around what's already here. I can do that by entering a triple quote here. And this is a triple single quote. I can also do a triple double quote here. But I'm going to put a triple quote at the beginning and the end. You know what I'm going to do it at? I'm going to do it as a triple double quote just to make it easier to kind of see. At the beginning and the end of this block, and that we call that a comment. And a comment just tells my code to ignore this part. So now we're going to ignore this part. We're going to do another calculation. We're going to do our calculation. So if we tried to run this now, it's going to give us nothing on the output because it's ignoring all the code we wrote previously. So let's do the calculation for finding the hypotenuse of a right triangle. Finding the hypotenuse of a right triangle. which is a squared plus b squared equals c squared. Right, so we'll start with just something easy, right? So we'll say print and we know the exponent, so we know how to get it to 3. So we'll say side A is 3, squared is 2. If we want to make sure, even though this is doing it with PEMDAS and exponent should be done early, if we want to make sure that this is done early, we can wrap it in parentheses. So that's our a squared plus b squared, 4 times 2. And so now we can see the results here. And this will give us $25. Now, if we were doing this equation in the real world, what we would want is we would want the length of side C. Right? So we'd want to get the square root of this value. Now, there's a little trick that, not a lot of people know about, I think, unless they are mathematics savvy, which would be to take the result of this, and I believe it is to raise it to the power or to the exponent of 0.5. Right, so now when we run that, we get 5.0. We get 5, which is the correct length, right? Because this is a 3, 4, 5 triangle. Right, so this is actually this is a type of algorithm that will allow us to find the length of the sides of, or the length of a hypotenuse of a right triangle using Python. Now, we can come in here and we can change these two numbers to whatever we want them to be and get a number as a result. And since we tested it using smaller numbers, we could assume that it's the correct answer. Now, with that being said, we've crossed 2 of our big things off the list. Right, we've crossed outputs off the list. And we've crossed math off the list. We've hit our hour, so I want to stop here. Next week, I want to do the other 3 of our things. I want to do inputs, which inputs will go pretty quickly. I want to do conditionals. And I want to do repetition. And I want to do them all kind of while, and also write a bit of a program next week as well. So this might require a little bit of supplement in order to be able to do all of this. We will see. We will see. So since we've hit our hour mark for today, we'll stop here for today. We've got much more to do with this, so there's more to come. Thank you for watching. I'll hang out into the chat just in case anybody who's here with me live has any questions for me. For just a couple minutes here. But thanks again. We'll see you next time.